Welcome to the deep dive. You've sent over some really interesting material about software testing, and it's a topic that definitely affects all of us, probably more than we realize.
Absolutely. We interact with tested software constantly.
So today we're going to get into, well, a really core idea, something fundamental to making sure all that tech we use every day actually, works.
Exactly. We're diving into black box testing. And maybe the easiest way to think about it is imagine your phone.
Okay.
You tap an app icon, right? That's your input. You expect the app to open. That's the output. You don't need to know how the code makes that happen. You just care that it happens. That's the core of black box testing, looking from the outside.
Right. Like it's literally a black box. We can't see inside.
Precisely.
We're just focused on, okay, what did I put in and what did I get out? Doesn't matter how complicated the wiring is inside.
Yeah, the internal structure, the specific code logic, irrelevant for this type of testing.
So based on the articles and things you shared, our goal today is pretty clear. Unpack black box testing, what it is, how it's done, why it matters so much.
Yeah.
But hopefully without getting too lost in the technical weeds.
Sounds like a plan. So that central idea again. We're testing software functionality, but purely based on the requirements, the specifications, what it's supposed to do. You often hear it called behavioral testing.
Behavioral, right, because we're watching how it behaves.
Exactly, how it reacts to different things we do to it.
And reading through the sources, what really stood out was just how broad this is. It's not just for, like, little apps.
Oh, definitely not. We're talking big, complex systems, operating systems like Windows, massive websites like Google.
Databases, too, like Oracle.
Yep, those as well. And, as the material highlighted, any custom apps you might build. The common thread is always inputs and outputs, that relationship. And actually, by focusing just on that observable behavior, testing becomes much more efficient in a way. Well, you don't have to pore over every single line of code. Instead, testers use specific techniques to get good coverage without needing, millions of tests.
Okay, that makes sense. So how do they actually do that? How do they design these tests smartly? The first technique mentioned was equivalence class testing.
Right, equivalence class testing, or equivalence partitioning sometimes. The basic idea is you take all the possible inputs and you divide them into groups or classes. And the thinking is any input within a specific class should be treated the same way by the software.
Okay.
So if you test just one value from that class and it works, you can be reasonably confident the others in that class will work too.
Ah, I see. So it saves you having to test every single possibility.
Exactly. It drastically reduces the number of test cases needed.
Like if you're testing an age field, maybe 18 to 65 is one class, under 18 is another, over 65 is a third, something like that.
Precisely. You'd pick maybe one age from the valid range, one below, one above. If those work as expected, you've covered the core logic for age handling pretty well.
Got it. Okay, then the material moved on to boundary value testing.
Yeah. Boundary value testing, or BVA. This one zooms in on the edges.
The edges.
The limits, the boundaries of those input ranges we just talked about. The sources rightly point out this is super useful when you have fields with clear minimums and maximums.
Right, because errors often happen right at those transition points.
That's exactly it. So using your age example, instead of just testing, say, 30, which is well within the valid range, with BVA, you'd specifically test the minimum allowed age, maybe 18, then one just below it, 17, which should fail.
Okay.
Then the maximum age, say, 65, and one just above it, 66, which should also fail, plus the exact boundary values themselves.
It's about probing those critical points where the logic might switch or, well, break, like those off by one errors you hear about.
Exactly what is good at catching. If something requires, say, a password between 8 and 16 characters, you absolutely test a 7-character one, an 8-character one, a 16-character one, and a 17-character one. Those boundaries are key.
Makes sense. The third technique was decision table testing. That sounds a bit more structured.
It is, yeah. Decision tables are great for more complex logic where multiple conditions influence the outcome.
How do they work?
You basically create a table, a matrix. The columns represent different combinations of input conditions or causes.
Okay.
And the rows map those combinations to the expected actions or effects. It's a systematic way to make sure you've considered all the important rule combinations.
So you don't miss tricky interaction scenarios.
Precisely.
Yeah.
Especially useful when business rules get complicated.
All right, so those are strategies for designing the tests. The sources also talked about different types of black box testing. functional testing was first.
Yep, functional testing. Yeah, it's exactly what it sounds like.
Testing the function.
Testing the specific functions, the features, based directly on the requirements document. What is this thing supposed to do? Let's check that.
And the sources said this is mainly the job of the software testers.
Typically, yes. It's their core bread and butter, verifying each piece of functionality works as specified.
Okay. Then there is non-functional testing. That covers sort of everything else.
Pretty much. Everything around the specific features.
Yeah.
Things like, how fast is it? That's performance testing.
Right.
Can it handle lots of users at once? Scalability testing. Is it easy and intuitive to use? That's usability testing.
Right. So quality aspects beyond just does the button work?
Exactly. These are crucial for user satisfaction, even if they aren't tied to one specific function in the requirements list.
And the third type mentioned was regression testing. This one sounds really important for ongoing development.
That's absolutely vital. Regression testing is all about making sure that changes like bug fixes or adding new features or system upgrades haven't broken anything that was working before.
Ah, so you don't accidentally introduce new problems while fixing old ones.
Precisely. It prevents that frustrating situation where an update makes things worse or breaks something totally unrelated. You run tests on the existing functionality to ensure it's still solid.
Okay, so we have these design techniques, these different types of testing. What does the actual day-to-day process of doing black box testing look like, step by step?
Well, the sources laid it out pretty logically. It always starts with really understanding the requirements and specs.
Got to know what you're testing against.
Absolutely. Then, the testers choose specific inputs to try out. And importantly, this includes both valid inputs, the kind you expect users to enter, and invalid inputs, things that shouldn't work, to see if the system handles errors properly.
Right, you need to test the error handling too, not just the happy path.
Crucial. Does it crash? Does it give a helpful error message? Or does it do something weird?
Okay, so you choose inputs, then what?
For each input you've chosen, you figure out what the expected output should be, based on the requirements.
So you know what good looks like.
Exactly. That's your benchmark. Then you actually create the test cases formal steps using those inputs. And then you run them. Execute the tests against the software.
And watch what happens.
Yep. You compare the actual result you get from the software with the expected result you defined earlier.
And if they don't match,
That's a defect, a bug. It gets reported, the developers fix it, and then
you test it again.
you retest to make sure the fix worked and didn't break anything else. That's where regression testing comes back in.
It sounds like a really disciplined cycle. Makes sense. Now, tools were also mentioned. What kind of software tools help with this?
Right. Tools are definitely used. They often depend on the type of black box testing. For functional and regression tests, you see a lot of automation tools.
Like Selenium, I think that was mentioned.
Exactly. Selenium is huge for automating web browser tests. QTP, now UFT, is another common one. They let you record test steps and play them back automatically.
Which must save a ton of time, especially for regression testing.
Immense amounts of time, yeah. Running hundreds of tests manually over and over is just not feasible.
And for non-functional testing, like performance.
For performance and load testing, tools like LoadRunner or JMeter are popular. They simulate many, many users accessing the system at once.
To see how it holds up under stress.
Precisely, to find bottlenecks and measure responsiveness.
Okay. Now, a really key distinction in the material was black box versus white box testing. Can you break down the main difference for us?
Sure. The absolute fundamental difference is perspective and required knowledge. Black box, as we've said, looks from the outside. It focuses on what the system does based on requirements. No need to see the code.
Okay. The what?
White box testing is the opposite. It looks inside. It examines the internal code structure, the logic paths, the actual lines of code.
So white box is about the how.
Exactly. How does the code achieve the result? Because of that, white box testing requires programming knowledge. You need to understand the code itself.
Whereas black box testing doesn't necessarily require coding skills.
Correct. You need to understand the requirements and how the system should behave, but not necessarily the specific programming language used to build it, which, as the sources hinted, is pretty practical given how many different technologies are out there.
Right. You can test almost anything without needing to be an expert in Java, Python, C#, everything. The sources also touched on communication, like between different parts of the software. How do they differ there?
Well, think about it. Black box testing often involves sequences of actions that naturally cross boundaries between different modules or components of a system. You put an input here, expect an output over there. So inherently, you end up testing if those modules are talking to each other correctly, just by observing the overall behavior.
Okay.
White box testing often focuses more on testing individual units of code, sometimes in isolation. So it might not catch those inter-module communication issues as directly.
That makes sense. Black box keeps that higher level user-facing view.
Mm.
Okay, final piece. How does all this fit into the bigger picture, the software development lifecycle, the STLC?
Yeah, it's not just something tacked on at the end, which is a common misconception.
Right.
The sources correctly point out that testing, including black box, has its own parallel lifecycle, the STLC, software testing lifecycle.
Yeah.
That integrates with the STLC from the very beginning.
So testers are involved early on.
Ideally, yes. Even during the requirements phase, testers participate to understand what needs testing and if the requirements are actually testable.
Okay.
Then there's test planning and analysis, where the overall strategy is decided, what types of testing, what resources, what are the risks. Then test design, where the actual test cases and scripts are created based on those requirements and the techniques we talked about, like equivalence classes and boundary values.
And finally, execution.
And execution, yeah.
Yeah.
Running the tests, logging the bugs, working with developers on fixes, and retesting. It's woven throughout the entire development process.
Wow, okay. We've definitely covered a lot of ground there.
Yeah.
So pulling it all together, black box testing is really this essential method for checking if software does what users expect.
From the outside looking in.
Focusing on the functions, the usability, the performance, using smart techniques like equivalence classes and boundary values.
Right. To get good coverage efficiently.
And it's happening all through the development cycle, not just at the finish line. That black box idea seems really powerful for handling complexity without getting totally bogged down.
It really is. It allows testers to focus on the user experience and the requirements, regardless of the underlying tech stack.
It definitely makes you think, doesn't it? Like, consider the last time an app or a website just didn't work quite right for you.
We've all been there.
What kind of black box test, thinking about the input you gave and the weird output you got, might have caught that specific issue before it ever reached you?
That's a great question. Or think about how much software needs to run on different phones, different browsers, different operating systems.
Yeah, the variety is huge.
How critical do those techniques like equivalence classing and boundary value testing become then to ensure it works reliably for everyone on everything? It's definitely food for thought.
Absolutely. Well, hopefully this deep dive gave you a clearer picture of this crucial testing approach.
Indeed. And, if this sparked more questions or if there are other software development topics you're curious about, definitely let us know. Always more to explore.